In this video, I'm going to talk about the law of sines and how you use it to solve triangles. So this is if you do not have a right triangle, so your typical sine, cosine, tangent ratios don't always work. If you remember your SOHCAHTOA, right triangles will still work using law of sines, but law of sines is not limited to right triangles. It is allowed to be used with any kind of triangle. So our general law of sines would be sine of alpha divided by side A, sine of beta divided by sine B, and sine of gamma divided by sine C. And our situations where this arises, if you recall from geometry, we had like side, angle, side, angle, side, side. We had those various triangle properties to prove congruent triangles. Well, law of sines works when you're given an angle, side, angle, or also the side, angle. And remember, I know when I teach geometry, I always talk about there's no bad words in math. Well, side, angle is that situation where you couldn't use that to prove triangles congruent, but those situations still occur. And so these are the three situations in which law of sines will apply. And I will also point out to you that for our law of sines, these sides and these angles, I'm going to kind of offset my triangle here. So these sides and these angles, what happens is these are opposite each other. What that means is, let's assume that this angle right here is our angle alpha. That means that this side opposite of it is side A. If this angle is my angle beta, that means this side is side B. And if this angle here is my angle gamma, this side is my side C. So they're always opposite each other. All right, so let's practice using these. Now, our angle, side, and our angle, side, angle, they're the easiest ones to use. Either you're going to have a triangle or you're not. Let's go ahead and label some things on this triangle just so we can kind of help ourselves out here. So I'm going to label this one as my alpha, beta, gamma, which makes this side A, B, and C. And does it really matter? No. My picture is not drawn to scale. And in fact, you could probably look at this and be like, yeah, that definitely is not right. But it's more of the generalization to figure out how I'm going to lay things up. If I am given two angles, I can easily find the third angle. Because remember, all of our triangle angles add up to be 180 degrees. So all I would need to do is add together that 75.8 and that 45.1, and then subtract that from 180 to get that missing angle, which in this case would be 59.1 degrees. So I've got all three angles now. Now let's set up our law of sines. So I'm going to have sine, I'm going to start with this 59.1 degrees. So that's my gamma, which means it goes over side C. And then that's going to equal, let's start with sine alpha. And our sine alpha is going to be over the A, which, hold on, I need to put actually the angle in there. So our angle alpha is 45.1 degrees. And this is going over top of our A. And at this time, we'll just do some cross multiplying and then divide by the sine 59.1. Now, when you are typing this in the calculator, make sure your calculator mode is set to degrees. Otherwise, it will give you a wrong measure. Because if you're in radians, our angles here are not in radians. So like I said, cross multiply and divide. We're going to end up with A equaling 8.4. I'm going to stick with one decimal because that's what we have up there. And these are in inches. So we'll go inches. Now we're going to set up another ratio. So we're going to have, we can go ahead and keep this sine 59.1 degrees and the 10.2 because those are both exact measures. The 8.4 is a rounded measure, so I try not to use that unless it's absolutely necessary. All right, and so now I need side B. So I'm going to use beta. So I've got sine beta, which is 75.8 degrees over B. Now, why did I label our triangle up here? This is more just if you couldn't remember what sides are over what sides here, they're always opposite things. So you could label in the triangle our measures here, and that would be perfectly acceptable as well. So you're going to go through and do this calculation now and do 10.2 times sine 75.8, and then we're going to take that and divide it by sine of 59.1 until we get our beta. So beta is going to be that 11.5. So 11.5 inches. Couple things that you can do to check yourself. Remember, our largest side is always across from our largest angle. Well, our largest angle is this angle beta. Well, is 11.5 our largest side? Yes, it is. So that works out perfect. All right, so our final answer on this one, we're going to have A equaling 8.4 inches. B is going to equal 11.5 inches. And gamma, so let's go to our Greek letters here. Gamma is going to equal 59.1 degrees. So that's going to be our final answer on this one. All right, so there's our final answer. Well, let's try another example. So remember, this was our angle, side, angle. So we had beta, we had alpha, and we had C. So angle, side, angle. All right, let's try another one. So now this one's going to be angle, angle, side. But once again, anytime you are given two angles, it is super easy to find that third angle. Really, all you have to do is add them together and divide by, or add them together and subtract it from 180. Okay, so finding our angle measure here. So we're going to do 63 plus 38, and then do 180 minus that. So we get our angle measure for our gamma angle to be 79 degrees. All right, and now we can use that to actually set up and find our other angle, or our other side measure. So let's set up our ratios here. This time we're given side A, so we'll have to use our sine of A, or sine of alpha. So sine of alpha will be 63 degrees, and we're going to put that over top our 12. So that's going to be kind of our baseline ratio for all of our proportions here. It doesn't really matter which one we find next. It's entirely up to you. So let's go ahead and find B. We'll go ahead and use beta here. We're going to find side B. So once again, we cross multiply and then divide by this. And then our last ratio that we're going to set up would still be this sine 63 over 12, but now we'll do 79 over C. So solve those proportions, and then we can actually find what these measures are. Let's pop in here. Okay, so starting with B, so we've got, and once again, make sure your calculator is in degrees, because if you are not in degrees, it is going to cause a problem. So this one would be 8.3, and once again, we are in inches, so let's just go ahead and put our labels on things, because that's, make sure you label what you're working on. And then to find side C, kind of solve the same idea. And remember, this one, since it's our largest angle, should be our largest side. So we have 13.2 inches. And there's our answers for this one. Now, once again, these are pretty straightforward. It's when we get to the side-side angle situation that we have other problems. Then we have a possibility, which I do want to come back and talk about these. It is possible that you could not form a triangle with these. And the way you would determine these is if these two angles right here added up to be more than 180, there's no way to make a triangle out of that, in which case you would just write no triangle possible, or no solution, or something along those lines, so we know that there is not a triangle here to solve.